Last episode, we dove into the well-known Pythagorean theorem, a squared plus b squared equals c squared. There are many whole number solutions to this formula, fittingly named Pythagorean triples. Some common ones are 3, 4, 5, 6, 8, 10, 5, 12, 13, and 7, 24, 25. But what if the three numbers aren't squared? Well, it turns out that it gets a lot trickier after that. The answers lie in the mystery of Fermat's last theorem. Let's take a look. The beginnings of this problem, and other problems like it, date back to the great mathematician Diophantus of Alexandria, who lived around 50 AD. His most prolific publication was Arithmetica, where much of his works were in the area we now know as algebra, despite geometry being the dominant field at the time. The ancient Greeks were somewhat limited in notation as their number system just used alphabetical characters. But Diophantus did begin to create some notation for unknowns and for exponentiation. His book contained many expressions similar to the one I mentioned before. The problem stood the test of time and baffled many mathematicians, that is, until Pierre de Fermat in the 1600s. Fermat would write notes in his copy of Arithmetica. The notes were things like, "I can prove this, but I have to go feed my cat," or "I can prove this, but I gotta go and wash my hair." Fermat never cared to actually write down any of his proofs, and he died by the time his book was discovered, so nobody could ask him either. Over time, the math world eventually devised proofs for all the problems next to which Fermat had his annoying little quibs. That is, all except one. The last one standing without a proof became known as Fermat's last theorem, and the note next to that one was, "I have a truly marvelous proof, which this margin is too narrow to contain." That problem happens to be the one we talked about before. A to the n plus b to the n equals c to the n, where all the numbers are integers. The story goes that a young boy named Andrew Wiles became fascinated by this problem since he was 10 years old. Time passed, but he never made any progress on the problem despite his mathematical studies through college, graduating from Oxford with a PhD in 1974. It wasn't until 1986, 12 years later, when reading some other work on the topic, that a conjecture called the Taniyama-Shimura conjecture was connected to the famous Fermat's last theorem. He realized that if he proved Taniyama-Shimura, he would have what he needed for Fermat's last theorem. The story says that Wiles disappeared from his regular life for almost 7 years because he was so focused on this problem. Eventually, he succeeded and began finally telling the math world about his results. However, an error was found in his proof, and it took another whole year before he was able to work out the flaw and finally publish the results. All this work begs the question, did Fermat really have a proof to this complex problem? It took Wiles over 7 years to prove it after all, and Fermat just knew? The most likely answer is that Fermat merely thought he had a proof, when in reality, it wasn't sufficient to prove it entirely. After all, the mathematical tools used by Wiley were out of reach of Fermat at the time. Plus, when Wiley made a mistake in his proof, he had professionals to detect said flaw, where Fermat's work was entirely on his own. It is very unlikely that he had a full drawn-out proof in his head, but maybe there is a simpler version of the proof that we just haven't discovered yet. Well, that's it for now. If you would like more details on the legend of the proof, check out the video by Numberphile, which I'll put in the description. Be sure to join us next time as we study the man known as the father of algebra, who came from a region we might not expect.